everywhere. How about this trinomial? Two numbers that multiply to get 9 and to get 6. 3 and 3. Which means that must be a perfect square. How about t squared minus 4? Plus 2t minus 2. Which is squares. Squares factors easily if you recognize it's a different square. And then this is where you whack out common factors. And ladies and gentlemen, if you delight as much as I do in whacking out common factors, please feel free to smile during this time. So, and if you want to give a little chuckle or chortle, you may. No guffaws. That's about it. Okay? Not bad. But notice what it required. It required that you are able to factor. You can't factor those guys, you're not going to see common factors. You get some signs mixed up? Uh-oh. So there's a real need to be able to factor simple polynomials to be able to work these multiplication problems. All right, next concept, division. Let's look at number 52. All right, we're dividing fractions. Who can give me an explanation of what to do when we're dividing fractions so that an elementary student would understand what you're saying? What do you think?
Flip the second fraction upside down, flip it around, and make a multiplication.
All right, so you got two things to do, right? Change to a multiplication and take the, what do you call it? Reciprocal of the second fraction. Anybody got a little handy way of saying that? I'm sorry. Something like that.
Copy, change.
Copy, change, flip is one way to put it. Have y'all heard that? Copy the first one, change to multiplication, and flip the second. So copy, change, flip is that way some people put it. And that, your little poem goes something like, don't ask one, flip the second and multiply.
How about just cross multiply?
Okay. Okay, but the reason we don't cross multiply is because what goes on top? Okay, that's one easy thing to forget or to get mixed up. You can cross multiply, but you got to stop. You got to start upper left, and then secondly, lower left. So I wouldn't do that just because of the potential for getting your which one on top. Yes.
It's 2y plus 6.
Oh, it's 2y plus 6. Okay, thank you very much. We have a change here, ladies and gentlemen. Plus 6. Thank you. All right. So when dividing fractions, don't ask why. Just flip the second and multiply. Hey, we're on familiar turf, right? We're back to the multiplication problem. I know exactly what to do. Factor everything on top. Factor everything on the bottom. Look for common factors. How does this guy affect? Thank you. Common factors. So we always look for first. How about this guy? Got a 2. See that? Always, always, always look for a common factor first before you do anything else. How about this guy? 5 times. Okay, and here's where I see common factors. Aha, I see a y plus 3. So it's out there. I guess that's about it, huh? Oh,
Opposite.
somebody see something else?
Opposite.
What is y minus 4 and 4 minus 5?
Opposites.
They're a pair of opposites, ladies and gentlemen. That's right. Be honest now. How many of you recognize they were opposites? Good. But as we start getting more and more familiar, and seeing them more and more often, we'll recognize them more quickly as opposites. Hey, can I cancel these opposites?
No. You leaving
Yeah,
negative
that's the
1.
whole point. I can cancel the opposites. What do I have to do?
Negative 1.
Introduce a negative. All right? So I got 8 over 5. And I can introduce the negative on the top, in front, on the bottom. That's typically the way you write it, right?
So it doesn't matter where you put the negative.
It does not matter where you put the negative. It might to Web's sign, but it doesn't to me.
Okay.
That's right. So, understand that negative 8/5 is the same as negative 8/5 is the same as 8 over negative. Those are all the same. Put any of those in your calculator and you're going to get exactly the same value. And these are kind of reflective of the times of our lives, ladies and gentlemen. When I was wild and crazy back in the 60s, I used to put my negatives in the denominator. Don't hold it against me, all right? I was kind of crazy back then. When I got a little bit more, I got married, had kids, I put it in the top just because I thought I ought to be a good example. Now, in my more conservative, older years, right there in the top. So, just know that you can put it anywhere you want to, and it won't hurt anything. Anybody got a question on this guy? Don't ask why. Let me say, all right. So we've got multiplication down, we've got division down, no problem. Now we go to what typically are easier operations, addition and subtraction. But with fractions, they're more challenging. Why? Common denominator. You remember that. If I'm adding or subtracting, i.e. combining fractions, even fractions that involve polynomials, I gotta have the same denominator. So let's look at some simple examples. Let's start with number 57. First thing you might notice is I don't have two fractions here. Can you remedy that problem? Yes.
Put 6 over 1.
Sure. Anytime you want to, when you need fractions to exist, you can always put something over 1. Doesn't matter if it's got a variable in it. Doesn't matter. Anything is the same thing over 1. Okay, that's a little help. I got a fraction minus a fraction. Now I need a common denominator. Here's the concept of common denominator. The common denominator involves every factor, and those are things multiplied, right? Every factor that shows up in either, or I should say any, of your denominators. So I check out my denominators. I find out what factors show up there. Those factors have to go into my common denominator. So what's going to be the common denominator for this guy?
X plus 3.
X plus 3. I've only got two factors, 1 and x plus 3, and 1 doesn't really count because there's that identity element for multiplication. So you're right. My common denominator is x plus 3. So I want to express both these fractions in terms of a denominator of x plus 3. So this second one's already there. As Mozart said, if it ain't Baroque, don't fix it, right? So this ain't Baroque, so don't fix it. Leave it alone. All right, here's the concept. Here's the way I phrase it. What did I multiply my old denominator by to get my new one?
X plus 3.
X plus 3. So I have to multiply my old numerator by the same thing. So what we're really doing is multiplying by something over itself. We're multiplying by some form of